Hi everyone, my name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology, Hyderabad. I welcome you all with another video lecture on stream processing and analytics. The today's topic is the use of batch processing component in a streaming application. Okay, how we can mix batch processing in a streaming application. Now let's move on to the overview of today's presentation. Okay, I have divided my overview in two parts. As the first part, we are going to discuss the use of batch processing component in a streaming application, how we can apply batch processing in a streaming application, and as a second part we are going to discuss differential streaming architectures. So here it has divided into two again, the lambda architecture and the kappa architecture, which we have discussed a simple introduction in the previous video. Now let's move on to the first topic. So what is the use of batch processing? Okay, the most data engineers don't just solve a problem only once, but revisit their solution and continuously improve it. Okay, here if the data engineers are working with the data, okay, they not only solve problem only once, multiple times they will go to check their results, right? So it is a multiple repeating processes. Okay, so especially if revenue money is tied to performance of their solution. Okay, if the processing is related with the money. Why? Because the data analysis has to take only the limited sources, and we can get the proper outputs. For this purpose, a batch data set is used to set a benchmark. Okay, here we can use the batch data set. Okay, we can use the batch data set to store the data physically. After it's collected, it does not change anymore and can be used as a test data. Okay, here after once we collect the data we can store on the batch data sets. Okay, after collecting the data we can store it on a batch data set. So here we can use this data in a multiple times as a test data. Okay, multiple times we can take this test set. We can replay a batch data set to streaming applications to compare its performances. Okay, here we can use multiple times. We can replay a batch data set multiple times to achieve the streaming application analysis. Okay, so what is the difference between batch and stream processing? How they are interacting with each other? So we identify three levels of interaction between. Okay, we have identified here three levels of interaction between the batch and streaming processing components. What are those three interaction levels are? The first one is code usage, code reusage. Now we'll discuss what is the difference between batch and stream components and how we can connect both. Okay, we identify three levels of interaction between the batch and stream processing components. Here we can say the relation between batch and stream processing, the interaction is divided into three parts. The first one is code reusage, the second one is data reusage, and the third one is mixed processing. How the batch and stream processing will interact by using these three levels we'll discuss. Now we'll move on to the first, code reusage. It is easy to call functions that transform resilient distributed data sets and data frames. They share most of the same APIs, and only the data input and output is different. Okay, here we can say that most of the data, RDDs, okay, call functions, have functions, right? So these RDDs call functions, they share most of the APIs. Okay, if multiple data RDDs are working, they can share, is there chance of sharing the data. So we can call it as a data, here data manipulation process will make easily by sharing the code. Yes, so here we can call it as a code reusage. Okay, code reusage. Now what is data reusage? A streaming application, okay, if you take streaming application here, feeds itself from a data source at regular intervals from batch processing jobs. Here the streaming application takes the data from batch processing only. Batch processing only. This is the stream processing, stream application, and it will collect the data from batch data sets. Okay, as a part of job processing. Okay, that is nothing but the data reusage. Okay, the data reusage between batch and stream processing. Then we'll move on to the last, mixed processing. Then what is a mixed processing? The application has both batch and streaming components. Okay, every application has both the batch and stream processing. So this is used to manage the accuracy of insights of an application. Okay, here by combining both stream and batch processing, this will increase the accuracy of insights. Okay, next the maintaining the versioning and the evaluation of the application. Okay, here with the combination of stream and batch processing, we can maintain the version properly and evaluation of the applications as well. Now we'll move on to the second topic, that is nothing but referential streaming architecture. Okay, what is the referential streaming architecture? We'll discuss now. Our main concern is about how to measure and test the performance of a streaming application. Here, the main goal of the streaming architecture is nothing but the measuring and testing the performance of streaming application. Okay, how the streaming application is working, the performance we have to measure. So there are two things that can change in our setup. Okay, we can change our setup in a with respect to two things. What are those two things? Are the first one is nature of our model. Okay, we have to observe, focus more on the nature of the model and the data that the model is operates on. The second thing is that the data. Okay, as a to measure the performance, we need to focus more on the nature of the model. The first one is nature of the model, and the second one is the data which this model is operating on. So for example, if you are processing data from weather sensors, okay, here the data from weather sensor continuously monitored and recorded by some machines, right? So we can expect a seasonal pattern of change in the data. Okay, we can expect seasonal pattern. Why? Because with every season the data has changes, right, with the sensors. So that kind of data has to be, we have to focus more on. We have already understood that using a batch data set or two versions of our streaming application is useful. Okay, here in the previous video we have discussed, we can use both batch as well as stream data structures, right? Okay, now also comparing stream processing with the batch processing is necessary. We have to focus the comparison of batch and stream processing as well, how the both are working parallelly. So as a part of referential streaming architecture, it has divided into two parts. The first one is lambda architecture and the second one is kappa architecture. So now we'll discuss what is lambda architecture. The lambda architecture is a data processing model. So we can call it as this is a data processing model. This is the model that uses a combination of batch and stream processing to handle large amounts of data. Here we can say lambda architecture is a data processing model. It is a combination of both batch as well as stream processing, to handle a large amount of data. It's common. It is a common model used by businesses to make sense of big data. Okay, here it is mostly used by the business purposes because most of the businesses have the batch data sets as well as the stream data sets, right? So those data are collected via lambda architecture and they are performed by using this processing model. It proceeds from the idea what we want to emphasize 2 points beyond the accuracy of the data analysis. Here by using this lambda architecture, how we can emphasize the accuracy of the data analysis, the historical replay. Here by using the lambda architecture, we have to focus more on the historical replay. Why? Because as a part of batch we have to store the historical data, ability of data analysis, replay ability of data analysis. Next, the availability of results proceeding from fresh data. Okay, as a part of stream processing, we are going to work with the fresh data. Okay, as a part of historical data analysis, we have to use the batch processing. So analyzing historical data by using batch processing has to parallelly work with the processing of fresh data which is going to added in the processing model. Okay, here that is the reason we can say that lambda architecture is a combination of both streaming and batch processing. Here if you can observe in the diagram, if this is the input, here input has to share between the batch processing and next is stream processing. Okay, here you can see batch processing job and the stream processing step 1 and next stream processing step 2. Okay, after step 1 stream processing, it will go to the stream processing step 2, but here as a part of batch processing only we can call the entire batch as a one job. Okay, if we can discuss about the stream processing, it is a step-by-step process. Okay, here step 1, step 2, step 3, it goes in a stepwise process, but here batch processing works in a combination of all. So here we can call it as a batch processing job. Okay, after that, again the outputs are aggregated through the aggregation. Okay. Now, drawbacks of architecture. We'll discuss what are the main drawbacks of Lambda architecture if we follow that. This is a useful architecture, but it has a drawbacks. Even though Lambda architecture is useful by the businesses, but it has some drawbacks. Setup is complex. Here, the main drawback is that the setup is complex. Why? Because as it has a stream as well as batch processing. So with related to stream processing, the resources have to handle with respect to batch, the resources have to handle individually. So that is the reason we can call it as a setup is complex, requires maintaining two versions of the same code for the same purpose. Okay, here as a part of processing, we are dividing our code into two versions, right? So as a stream processing model version, okay, and the batch processing model version. So we have to maintain two versions of the same code. That code is same, but we have to handle the two versions of the same code. That is the reason it is a complex, and for the same purpose we are doing for the same purpose, right? Even if Spark helps in letting us reuse most of our code between the batch and stream versions of our application, the two versions of the applications are different in software life cycle, which might seem complicated. Though in the previous lectures we have discussed, we can maintain a stream and batch processing, and there is a interaction between these two, that is nothing but the data reusage. We can share the code as well as data between these two, though it has giving that kind of advantage, even though we have to work with the different life cycles of different patterns. We have to work with the different life cycles of different patterns. That is the reason it is a little bit of complex to set up. Now we'll discuss the Kappa architecture. What it is? The Kappa architecture compares two streaming applications and does not do any batch processing. Okay, as I have told you in the previous slides, okay, it is a combination of only one streaming application. In both the things, it will follow streaming applications only. There is no batch processing involved in Kappa architecture. Even the code that helps in feeding data to two versions of the applications can be reused. Okay, even though the data has come in a two versions, okay, let us take batch as well as stream. Okay, that batch data is converted as stream only. That is a beautifulness of this, a beauty of this Kappa architecture. Okay, here though we have two versions of okay, now we'll discuss the Kappa architecture. Okay, as a part of second streaming referential architecture, we'll discuss the Kappa architecture. Okay, now we'll discuss the Kappa architecture. This architecture compares two streaming applications and does not have any batch processing. Okay, here in Kappa architecture, both the versions follow stream architecture only. There is no batch processing involved in Kappa architecture. It is only works with the two versions of streaming applications. Even the code that helps in feeding data to two versions of the application can be reused. Okay, even the data has come in two versions. Okay, let us take batch and stream. So the batch processing data has immediately transformed as a stream only. So, and again it works with the two stream versions. In this method called the Kappa architecture, there is no deduplication of the data or model. So it is very simpler, we can call. So we need not to duplicate one stream processing to batch processing. Okay, need not to convert stream to batch. So there is no deduplications. We can call there is no deduplication. So we can call it as this model is very simple to handle, and there is no dependency data sources when comparing with the software life cycles. Here you can observe streaming job version n. So here n is nothing but the total number of steps. As I have told you, there is no job at a time job in a streaming application. It works with a step-by-step process. So here streaming processing step 1, stream processing step 2, stream processing step 3. As a part of output, it will store on any database serving layer. Okay, database. Now there are some use cases, situations for which still useful to implement a batch version of our analysis and then compare it to our streaming streaming processing solutions. There is some use cases which batch versions are converted into stream processing, and we can compare both the things. Thank you.